Okay, so in the last video, we talked about how to complete the atomic structure in regards to this chart. Now we're going to talk about is this chart down here with isotopes and then the isotope worksheet. I'll briefly go over that with you guys as well. So before we get started on that, if we go back to our notes, you did take notes on isotopes. So iso in Latin means equal or the same. So an isotope is basically when you have two elements that are exactly the same, which means in that case, if you remember what we talked about in the last video, if they are the same element, that means they have an equal number or the same number of protons. So that's where they're going to be identified as the same element, okay? So for example, like if we have carbon and carbon, both of them are going to be, if we take what we said earlier, they're each going to have 6 protons, okay? Now, if they have 6 protons, they must then have 6 electrons, okay? So the only thing that differs between these two carbons is their mass number, okay? So let's say we have carbon 12 and then carbon 14. So they do not have an equal mass. They only have they have these as the same, but there's something that's different. So if you remember the notes, it talked about how with an isotope, you have a different number of neutrons. So why is it that they have the same number of protons, but not the same number of neutrons? So if you remember in our last video, we talked about how the number of protons, that is the element's fingerprint. So, and also protons have mass, which will influence the mass number. But because we cannot change the number of protons, and without wanting to change our overall element, we're going to leave the number of protons alone, which means the only thing we can change is then the number of neutrons. So by changing the number of neutrons, we're not going to end up changing the chemical composition or structure of this element. We're just changing the overall mass number. So just like if you decide to dye your hair or change your fashion style, you're still going to be who you are. You're just changing your overall appearance, but you're not changing yourself entirely. So that's kind of like what's happening here with isotopes. We're just simply are changing the mass number. So as we mentioned here, those are going to be the same. So the only thing we need to figure out now is how the number of neutrons differ. So the way that we determine that is using what we talked about up here, subtracting the mass from the number of protons. So for carbon 12, we're going to do 12 minus 6, and for carbon 14, we're going to do 14 minus 6. So 12 minus 6 gives us 6, 14 minus 6 gives us 8. So for the number of neutrons, that is how they differ with these isotopes. Now the way that you set this up would be you would put the mass number on top and the atomic number on bottom. Okay, so for carbon 12, I would write this as C12,6, and then for carbon 14, it would be 14,6. Okay, so keeping that in mind, let's take a look at our table. Now, when you are looking at these four, just keep in mind that you need to go back and add the mass number up here. Okay, so that kind of follows the structure as well. Now for the mass number, I did not provide that to you guys, so you have to look at the bottom number for the periodic table. But as you can see, not all of the elements are going to be a whole number. So like for example, the sodium, I would round 22.99 to the nearest whole number, so that would be 23, and I would use that to figure out the number of neutrons. Okay, so I'm just showing you guys that real quick for the rest. And then let's take a look at oxygen 18. So oxygen is all the way over here. It has a mass of 16, so that's how it differs from the mass of 18 that is here on our paper. It has an atomic number of 8. So let's go ahead and put that. And we know that the mass we're going to be using for oxygen is 18, so let's go ahead and just write 18. So then we have 8 and 8 for the number of protons and electrons. So to find out the number of neutrons, we're going to subtract 18 from 8, which gives us 10. So that's how you do this chart. So this chart is very similar to the first one, but it talks a little bit about isotopes. So I just wanted to show you guys that part. Now for your isotopes worksheet, just kind of keep in mind what we talked about earlier with the structure and how the number of neutrons is what makes it an isotope. And then at this chart at the bottom, I really like this because it kind of shows you guys side by side, kind of like what we did with the 2 carbon isotopes. It shows you side by side about how these elements are different and similar based off of their subatomic particles. So you have 2 isotopes of chromium and then 3 isotopes of lead to figure that out with. Okay, I hope this is helpful, and then I will see you guys on Thursday.